Lecture 10 of the course Computer-Based Applications in Soil and Water Science. Lecture 10 is composed of two parts, and this is the part 1. Install and run CropWat software for determination of crop water requirements. The first part represents the first case, determination of crop water requirements without import of ClimWat data and irrigation schedule design. We will study some topics related to this subject, then review and install of CropWat software. Then the steps to run and to output the data from the CropWat software. Input the required data, the data of soil and crop and rain. Then open session to calculate NCRW, open session for graphic result, ET node and ET node and rain millimeter per day and effective rain. First step, open session to design irrigation schedule. Some related topics. There are different levels or types of crop water requirement. Net, gross, total. Calculation of different level or types of crop water requirement. Net crop water requirement NCWR equal ET node multiplied by K sub C. K sub C is the crop factor. Node crop water requirement equal ET node multiplied by K sub C multiplied by 4.2 to obtain the units of meter cube per fiddan per day. Total crop water requirement TCWR equal NCWR plus leaching fraction LF. Gross or actual water requirement equals the total requirement multiplied by the inverse of irrigation efficiency minus effective rains. And this is a short review about CropWat software. CropWat is a decision support tool developed by the Land and Water Department of El-Hady. CropWat for Windows is a computer program for calculation of crop water requirement based on soil and climate and crop data. Why we use CropWat software? To develop the irrigation schedule for different conditions. Calculate of the scheme water supply for varying or different crops. Evaluate irrigation practice. Install the software. CropWat is composed. Thus we have to extract this software to the drive C. Then double click in the icon of CropWat setup.exe. Then we continue to finish the setting up processing. When we run the CropWat software, the main menu of this software will be displayed. It is composed of 3 bars: upper bar for the operation of processing, such as file, save, open, and editing file; charts for getting the graphic presentation, the graphic output, and setting. Left bar is the bar for target operation. This means when we going to elaborate some processes in the RAIN, we must first press RAIN icon in the left bar. In the case we are going to carry an operation or process on crop, we must press the icon crop in the left bar. The lower bar is composed of some folder to show some folders or directory where your data are saved. Input. We are going to run and get the result of CropWat software. We must at first input data. We input 4 types of data: ET node data, rain data, crop data, and soil data. Now we are going to enter the required data. First, ET node data. To input ET node data, press climate/ET node in the upper of the left bar. Then press new to open the file. Second, select the type of data. We have different types of ET node data which are referred by the red arrow. This is an example for ET node data for the region of El-Hady, south of Egypt. After having input ET node data, we're going to save this data. Thus press yes to save and write the file name in which you will save your ET node data for other processing later. Second type of required data are rain data. Determination of effective rainfall. Actually, the effective rainfall is a percent of the total rain, because some amount of rain are lost by the percolation through the soil profile or through the operation of surface runoff. USDA surface conservation developed a formula for calculation of the effective rains from rain data. To input our rain data, we must at first press the icon rain in the left bar of the windows of CropWat software. Then press new to open a new file to input the rain data. We write here the name of a station as the file name to remember the file name. After putting the rain, the formula of USCDA allows to calculate the effective rain, which is presented by the yellow column, which are percent of the total rain. Third type of data or required data are crop data. Press icon crop in the left up bar, then open. To select your crop, press dry crop. Then alpha, which contain the almost all crops. Press the crop which will be considered in our calculation. Fourth type or the type data are soil data. Soil data are total available water, maximum infiltration rate, maximum rooting depth, initial soil depth, moisture depletion. Actually, we did not input the soil data, but by selection of the crop and the soil type, these data are inputted by the CropWat software, because the software contains this data or this information. By our selection of crop and soil type, software refers to the standard table and put this soil data. Now we are going to calculate the crop water requirement for an crop. For this, we must open 4 files which are inputted. Input file, rain, crop, and the soil. Or you can open the session if you have already from the file icon, if you have already saved this file. Then press calculation. You will see here with the yellow color the irrigation requirement table. Here is the stage and the K sub C, crop factor, and AT sub C every day, and ATC each 10 days, and the effective rains and irrigation requirement millimeter each 10 days. Now we are going to get the graphic results. We press chart in the upper bar of the main menu to obtain the histogram of ET node. The vertical axis represents the ET node millimeter per day, and the horizontal axis represents the months. We can obtain, or we can get, the other graphic of rain millimeter and effective rain, as you see in the legend here. Then to to get this graphic, you must press charts here and then effective in the lower bar the type of data you want to present it graphically. 80 node rain, effective rain. In 3 dimension or no, you can get this graphic in 1 dimension or 3 dimension as you want. Going to the final steps, which is the design of schedule irrigation. First, you must open the session to design the irrigation schedule. This means you must open the session that contains the file of crop data and irrigation requirement which have been elaborated. Then press schedule in the left bar of the main window. Obtained the final result of irrigation requirement and also the design of irrigation schedule. First, that we see 2 parts, the different types of irrigation below the table, which will be clarified in the next slide. But we must here refer to the yield reduction. Here, at the red circle, we refer that there is no reduction because there is no deficit irrigation. Deficit irrigation equal 0. Here you see column of deficit 0, 0, 0. This means that the plants or the crop or the wheat was irrigated with the required amount. This meaning that the crop has received the suitable amount of water in the suitable time. This is the key factor of stress water, which will be explained in the next slide. And this is the deficit irrigation and no deficit irrigation, and 80 sub A percent, 100%. This means that the actual irrigation equal what we need, what the plants need. Water stress coefficient K sub C equal total available water minus root zone depletion, which is written or stored in a standard table in the software CropWat. RAW is the readily available water. The water stress coefficient K sub C allows to describe the effect of soil deficit on crop evapotranspiration. Here some calculation of the different water requirement and rain loss and total gross irrigation, which have obtained from our final processing. Here we clarify the figures of the table. Thank you.